Good afternoon, everyone. Hopefully the morning's talks were great and you got a chance to meet a few more people over lunch. For the start of the afternoon session, I'd like to just start by introducing Damon Kohler from Google, who's going to be speaking about rosjava.
Hey everybody, I'm Damon Kohler. I'm a software engineer at Google. I actually work in the Munich office, so this was a bit of a trick. So just quick to try and set up some expectations for the sorts of things I'm going to try and cover. This talk is pretty developer-oriented. It's not a tutorial, so if you're not familiar with ROS or you're not familiar with Java, some of this stuff might be, a little hard to understand, but I think it'll be okay anyway. All the code samples are pretty abbreviated, so don't expect to copy paste from the slides. That won't work. But what I am going to try and do is cover a lot of the high-level concepts that might actually be hard to extract from the documentation, or things that I think you might only be able to find in a venue like this. So just to kind of kick it off, I have a little video, because it was 1 year ago, actually, that we launched rosjava at Google I/O. So 1 year ago, we also launched cloudrobotics.com, which is basically sort of our landing page for the work we're doing with ROS primarily. You may have noticed that video was pretty Android heavy. It turns out that Java is probably not the main reason people are interested in rosjava. It's Android compatibility. Of course, there's lots of Java libraries and things like that you can make use of, and I happen to actually enjoy working in Java, which I guess is pretty obvious. But I think Android is the biggest thing. So there are quite some differences, I think, in the rosjava client library compared to some of the other languages. One of the biggest ones is actually that the entire thing was designed from the beginning to be asynchronous. So for those who are not really familiar with that terminology, asynchronous means that when you call a method that might take a long time to actually do whatever it is you intended to do, you give it some kind of callback. So that callback gets called whenever the method is done. And in Java, that's usually with an object, a listener object. And all of the APIs are written in that way. So you won't find a lot of the blocking calls that you might, like a service.call will take a callback rather than blocking until the response comes and returning it. It's also built on something called Netty, which is a NIO framework, asynchronous NIO framework for network stuff. It's really fast. It's well vetted, and so it's built from rosjava is built from the ground up with that. So asynchronous gives you better performance in many cases. You can always write non-performant asynchronous code as well, but it also I think one of the more important things is it helps kind of promote better coupling and cohesion through sort of encouraging developers to create nice components in many of the same ways that ROS already does. So one just simple example of asynchronous is when you create a new subscriber and you want to do something on when a new message comes in, you would add a message listener object. And then that would be called for every new incoming message. So another big difference is this concept of node versus node main. So whenever people talk about nodes in the ROS ecosystem, it's actually a little bit of an overloaded term, I found. So sometimes people are talking about more like a node in the graph. Sometimes you're talking about an actual process. Then there's, in the ROS CPP world, there is the concept of nodelets, which are, I guess, similar to node main, really, in rosjava. So the API actually, in rosjava, the API actually distinguishes pretty clearly between these two things. And a node is really actually about encapsulating some of the things that are required in order to have a presence on a ROS graph. So you have some sort of configuration that talks about or describes how that node should operate, how it should connect to a master, things like that. And it also gives you the factories you need in order to create things like publishers and subscribers. And then it gives you all of the clients to actually access some of the other things that are behind different protocols in the ROS graph. So that's parameters and talking to the master and talking to other nodes, actually. Depending on, I think many ROS users probably don't have or maybe don't have a lot of knowledge of what's actually happening under the covers with some of these APIs. But there's actually a pretty clear distinction at the protocol level of how these things work. And so the node just kind of wraps all that up. And then the node main is actually just a listener. So whenever the node gets started or shuts down, the node main is notified of this. And so basically you put all your business logic, you put your actual robot program into a node main instead of into your node. And this kind of lets you create something that is nicely asynchronous and really pluggable. So you can run all of your node mains in one process, or one JVM, rather than creating multiple processes per, one for each node, basically, which is the normal thing unless you're using nodelets. So the lifecycle events on the node main, you have just on start, on shutdown. There's actually also an on shutdown complete. And these get called as the node basically comes up. So on start is called once the node has all of its, has its slave server running and everything that it needs to do to initialize is all done. Then on start gets called. And at that point, in your node main, you're actually able to start doing things, making publishers, creating subscribers, that sort of thing. But the lifecycle events actually go beyond that into other objects that are used as well. So publishers, for example, you can add listeners to them that will be called when master registration fails or succeeds, when new subscribers are added, when it gets shut down, things like that. This is just a small selection of the ones that exist. And some of these things will actually be called multiple times. In the case of on master registration failure, that can happen repeatedly. And so you might actually see that event multiple times. So this is just a really bare bones node main. It's missing some of the methods even. But basically the node main extends the interface that is a node listener. And the only thing that it does when it extends that is to add this get default node name. So many of you know who have written a node, usually you give it some sort of name there in your main method that can be overridden later when you actually configure things to come up. And this method sort of serves that purpose. You'll also see that it actually returns something called a graph name. So oftentimes I've seen in various ROS client libraries that strings are usually treated sort of as the data structure to represent things like topic names and types and all kinds of stuff. So in rosjava, I actually tried to wrap those up into things that have a bit more meaning and possibly also contain some useful methods like graph name can return like a new root graph name, and then you can build off of them and you can resolve against them and things like that. Then you see the onStart method, and the onStart actually receives the node. So the node, remember, is it's not a process. It's actually something that gives you the ability to create all the stuff that you need to do in order to get your job done. But that comes down to then, the question is, well, where does the node come from? And that's actually taken care of for you. So we try to actually create lots more threads instead of processes, mostly because bringing up a JVM is actually pretty intensive. It would be a waste to not do this, and it also sort of allows for in the future to be smarter about the way that we communicate between nodes that are running on the same machine. There's not really a necessary, not a need for a socket when two nodes share the same memory space. So the node main executor is actually what is responsible for executing your node mains. If you're a Java developer, then the executor name there probably seems pretty familiar, and it does actually just wrap up a thread pool, an executor service. It's a bit of a fancy custom executor service, but it's still an executor service. And it actually also wraps up a node factory. And the node factory is what is used basically behind the scenes, and that is handed off to your node listener, and then that's what you would act on. So your main method, if you were going to write one yourself, which I don't recommend, would look something like this. And you would basically create one of these node main executors, and you would have your node mains that you've defined elsewhere, and you would just sort of execute them with your thread pool, and everything goes off. So another thing you won't find is spin. Spin is usually what you would see like in your main. You would just loop constantly until the node that you created is shut down, and do some business logic there. So you don't actually need to do that in a Java node. If you do have something that you want to loop through and do continuously, there is access to the same thread pool that the node main executor uses. Everything actually runs in the same thread pool, including all the network communications, so everything can be shut down cleanly in the end. But you actually can execute these things that are called cancelable loops, and that's just sort of a nicer version of a runnable that is an interruptible thread. It gives you a loop method, a setup method, and you can execute this against the node, and then when the node shuts down, it will actually clean up all these things for you. So you don't have to worry about how do I cancel all these threads when I'm done. That's taken care of. So what does publisher and subscribers look like? You can see that the publisher actually is made with generics. So they're typed according to the message type that comes in. When you create a new one, you're asking the node to create it for you. You give it the topic and then the message type. And I'll talk a little bit more about how messages work in a minute. Subscribers are basically the same. And then you can add a message listener. And so the message listener here is just an anonymous object from the message listener interface. Every time a new message comes in, you get called, and you do whatever you like with it. So services, also pretty similar. You create the server from the node, give it the service name, give it the type, and then the response builder is actually something I get questions about pretty frequently when people try to use services. And it's actually changed a little bit recently. But basically, the response builder is just a sort of an asynchronous way to deal with incoming requests, rather than saying like sitting there and waiting for the next request to come in and then doing something and returning the response. You just create this. You create an instance of something that builds that response, and then that is executed automatically, right, in a different thread and everything. So in the server, in the service server, all this stuff, it can actually be asynchronous, but the protocol kind of makes that really hard to do. Anyway, so the builder gives you actually a response in the signature, and that's what you use. So there's one response that kind of gets recycled, or you don't have to worry about how you create it in your builder. It's just a little bit easier that way. So you set up the response, and then you don't even have to return it or anything. It just gets sent to the client. And the client looks pretty similar. But you also see that rather than blocking or having client call actually return the response, you get a on success or an on error, and that's where you would actually deal with your response. So the client is also asynchronous. So now the messages. You saw previously that in the, for instance, on the new service client right here, this .type. So all of the messages are actually implemented as empty interfaces. And then those empty interfaces are backed by something called dynamic proxy in Java. So at runtime, there is an implementation that understands how to parse the message definition and create the actual implementation that will back one of these interfaces. So the interfaces have two constants defined on them, which is the type and the definition, and those are just strings. And then you use that string type to actually, tell Java what sort of message this is, right? So it goes and it looks that up, uses some reflection to find the message interface, and builds an implementation for you. So another interesting thing for Java is that the rosjava messages package actually has the entire world of ROS messages available. So whenever you actually add that dependency to your project, you don't have to think about in your manifest, which message packages you actually depend on. They're always available. And the reason for that is because it's actually really, really fast to build those messages, and it's very small. Since they're basically all just empty interfaces, it's just an easy way to go. Also, because all of the definitions are parsed at runtime, that means that in Java you can do clever things like shapeshifter, if you're familiar with that from C++. You can actually sniff definitions off the wire and then build a message that you could use yourself. So in order to create messages, you actually need to use a message factory or one of these nice little helper methods like the publisher has here, this new message. That's really just a convenience method that wraps up a call to the factory. So I've also had questions about, why is there a message factory? Why can't I just instantiate a message? Why is it an empty interface? And a lot of that has to do with trying to future-proof rosjava as much as possible. So the subscribers and the publishers and services and things like that in rosjava actually have no knowledge of how to work with messages directly. So the actual implementation for a message or the implementation for things that know how to serialize and deserialize messages, all of that stuff is actually hidden away in factories that get handed around. So it adds a bit of complication, but I think it can be hidden pretty easily with these convenience methods like the new message on a publisher. But it really adds a lot to the flexibility. So if you wanted to completely replace ROS messages with something like protobuf, that would be possible. So another big thing, and this is actually a pretty recent development, is the build system for rosjava is actually based on something called Gradle. Gradle is a really flexible, build by convention, Groovy-based build system. It's pretty popular right now. It's completely compatible with Ant and Maven and other Java build systems. But I think probably what everybody here is wondering is, well, why not rosmake? Why not catkitten? So it turns out that the Java ecosystem is really just fundamentally different than C++ and Python and things like that. And there's a whole plethora of frameworks available for building your Java project in one way or another. And if you try to step outside of that, then it just becomes very complicated very quickly. So these people, the people that created Gradle and people that created Maven, they put a lot of thought into this, and and it's just so widespread that dependency management through debs and trying to actually wrap things up to work with make or CMake just becomes more headache than it's worth. So this is a very Java-centric build system, but it plays nicely with the existing ROS stack, ROS packages. So this is what the a rosjava package directory layout kind of looks like, all the way up to the stack, and most of it looks pretty standard. In fact, if you've used Maven or anything similar to it before, it also looked familiar. You have this build Gradle script here, and this is the thing that actually defines how your build is handled. But then you also have, and this is the build by convention part. You have a source directory, and then below that a main and a test directory, and then a Java and a resources directory. So in Java builds, typically you have different scopes for for your dependencies and your source files. So when you ship a jar that is designed to be run, when you're shipping a jar that contains your node that you're going to run in production, it doesn't include all the test dependencies and things like that. Those are scoped differently. Those go under the test directory, and those are there when you actually want to run your tests. So the nice thing is that because of this build by convention, basically once you drop all your Java source code into these directories, you don't actually have to define where they are or anything in your build Gradle script. It just finds everything and does the right thing. And then the build directory is just where everything winds up. So that's the created directory from Gradle. Excuse me. So the basic build Gradle script here, and this uses the Java plugin. That's what gives us that nice build by convention. You set up your source, your Java version stuff. And then what actually becomes interesting here, I think, is the version and the group assigned to this particular package. So you're in Maven, you have what's called a coordinate system. And basically your Java package gets an artifact ID, a group ID, and a version. And so if you go to Maven Central, which is just a large online repository of various Java dependencies, you can find pretty much everything you want there. Everything is addressable that way. And so in your build Gradle script, actually the name of your package becomes the artifact ID. The group is, by convention, or best practices that we're working on defining, I guess, for rosjava. The group ID should be ROS and then your stack name. And then the version is the version, actually, of your package. So you have versioned packages with this. And then you can actually see an example of it in action here. So under the dependencies, we have a compile time dependency, which means it's got to be available all the time, pretty much. And then we have the stack, which is the group ID right here. That's the first part of the coordinate. Then the package name right here, rosjava, and then the version number. And then down here, we actually define the repositories where to look for that thing. So we actually, when you do a Gradle build, it creates a local Maven repository called your M2 cache, or just your local Maven repository. It looks there first because you may have made some changes, and those should be available there in your local cache. And then Maven Central is the online version where you would actually go and find things like Guava or JUnit or other things that are widely available. So, in order to run nodes, you actually need to use a different Gradle plugin. There's an application plugin, it's called. Thank you. And in the application plugin, you specify a main class name. And this is why I was saying you shouldn't write your own void static main, because there is one already written for you that does some nice things, like parsing all of the normal ROS command line flags and things like that. And that's called the org rosrun class. Basically, you just put that into your Gradle file, and then when you use the install app task, you can actually run from the package a node main directly. It knows how to load it and find it and all that other stuff, and then also parse any of the remapping arguments. So there's two lines underneath the main class name, the install app into and the dist zip destination dir. Those are actually a workaround from something that's in rosrun that actually ignores anything that's in the build directory, which is where these things would normally end up. So we just move them into a directory called dist, and then rosrun works as you would expect. Okay, so none of that had anything to do with Android, and we already said at the very beginning that Android seems to be the most interesting thing. So we'll get back to that now. First, I wanted to say that there's actually a ton of stuff for Android already available, and it's in the market right now. You could go download it on your phone, play with some of those robots over there using it. I think, so Chad Rocky is actually giving a talk. I don't know if that's today or tomorrow. He wrote the sensor driver and the robot monitor. Those are both really cool. There's at least a few different teleop apps. One's for making maps and playing with PR2. All sorts of stuff. But one thing that I really wanted to point out is that there's actually way more than you can do than just using Android as a UI, which seems to be the most popular thing right now. Android is really, it's an embedded PC, but it's getting more and more powerful all the time. So you could actually build a complete robot that runs off of it. So one package that I wrote recently is called Android ACM Serial. And this is a CDC ACM serial driver. So if you have an Android device that supports USB master mode, or USB host mode rather, you can actually plug in things like an Arduino and a Hakuyo. So I have a little demonstration of that. So that entire robot is actually running off that tablet that you see on the top. And this is Arviz, of course. And we're using it to build maps and navigate point to point, things like that. So it has the tilting laser scanner. That's actually being driven. It's just a hobby servo that we're driving off from the Arduino, and we're talking to the Arduino also over the USB channel. Excuse me. So what does an Android app look like, actually? Well, there's the Android core stack that provides the ROS activity, which is a nice wrapper around the normal Android activity. And basically what that gives you is an extra method called init, which gives provides you a node main executor that we talked about already, and then you can use that node main executor to just execute node mains like you would off of Android if you were writing just a normal Java node. So how does that get started? Well, so when the ROS activity gets started, it actually starts up a background service. And that background service, well, actually in Android they would call it a foreground service because it's persistent. It tries to stay alive. It starts that up, and then simultaneously it launches something called the master chooser. And that is the user's opportunity to choose what master in order to connect their application to. And then if the user cancels on that choice, decides they didn't actually want to do this, then the activity just exits. But once they've chosen, and once the node main executor service is ready, then your init method gets called with that node main executor. So there's a lot of stuff kind of happening under the covers there when you do that you no longer have to worry about when you use the ROS activity, which is like wake and Wi-Fi lock. So those are things that keep the phone alive, keep the network running, things like that you actually want when you're dealing with a robot. Deals with setting up that persistent background service, and it also provides the user with a notification so that they can actually cancel the whole thing. They can kill the app. It also defines a few patterns for Android development. One of those is that in Android we have concepts of views. So there's a text view or an image view, things like that. And then in ROS we actually take those same views. So you would extend a view or create a brand new view, and then implement node main with it. And then you can execute that when you get in your init method. When you get your node main executor, you can execute that view just like a node main. And now it serves both purposes. So you can actually drop it into your Android application layout, and then do ROS type stuff with it, create publishers, subscribe to stuff, things like that. And what that does is actually create data-driven UIs. So if you have the teleop app, for instance, and it has a map in the center and then a joystick, and we actually have on the joystick in the Android core, it will change the way it's displaying what's happening when you spin in place, for instance. It will show sort of an indicator of how far you've turned based on odometry messages. So you execute that joystick node, and then it creates a subscriber to the odometry, and it creates a publisher for CMD-vel, things like that, and gives you that whole experience all at once. So there are quite a few Android components already. This list keeps growing, I think. The nice thing is that if you go and you create, for your application, you create a view and you use this pattern, then it's really easy for other people to reuse your component. So the ROS text view and image view are just subscribers. They subscribe and then like to a string message and then display it, or to an image and display it. The camera preview view actually uses the preview. The camera preview view is what it's called, and it publishes those images. Then there's orientation publishers and joysticks. And then the visualization view is pretty new, and that is actually a XY orthographic OpenGL view that we used actually, you saw in the demo video, doing the navigation and the map building that uses that. Okay, so just briefly about some best practices. So Java packages. Basically what we're trying to do right now is to use whatever it is your domain is, like you would normally do in Java, followed by the ROS package name. And that seems to work out pretty well. So all of the ones that are core to rosjava right now start with org-ros. And so you don't want to start yours with that because then it gets confusing as to where it belongs to. For messages, there are quite some collisions with like existing Java types. So you want to be careful not to just import those. Like if you import string, bad things can happen. So in general, it's nice to just actually never import them and just use it because they actually have a very short package name. The package name is actually just the message package. And so you can just do standard messages.string everywhere. And then to use the convenience methods when they're available for what it is you're trying to do. So creating a new message factory or handing one around can be pretty problematic or cumbersome. And so if new message is there, look for something that will create what you want. And then of course, because everything is asynchronous, you should try to keep up with that. So prefer callbacks to blocking. I know in many cases it seems like blocking is the only answer, but usually that's not the case. So give it some extra thought. So currently what I'm working on is actually just trying to make sure that rosjava has feature parity with ROSPy, ROSCPP, things like that. Make sure that it's actually completely feature complete. It's pretty close. It's not quite there yet. And so along the way, I'm trying to stabilize the API. For those of you that have already been using it for quite some time, you know it changes pretty frequently. So, and I've also been working a lot on the documentation. So I hope that is helping everybody. Most of the documentation is auto-generated now from JavaDoc. JavaDoc is becoming more complete, and there's also Sphinx documentation checked in, and that tracks the release process, unlike the wiki. So, and overall, I'm just trying to push for a 1.0 release. So, a few of the future things I have in mind. There's been some work on doing OSGI type things, especially loading nodes over the network, along with their dependencies and things like that, controlling their lifecycle remotely. And then in order to support that, Groovy scripts for doing deployment, sort of along the same lines as the build scripts currently are. I'd also like to see sort of a pure Java deployment of ROS. So that means helper CLI tools like ROS topic and things should be available. And then some other things that maybe during one of the Birds of the Feather talk I would be happy to talk with people about is doing multiplexing topics over a single socket and sort of trying to rework some of the protocols that are currently in ROS that don't use topics to just depend on topics instead to sort of simplify the process of creating a client library. And that's it. So I think we probably have time for questions. Thanks. Okay, so the question was, it seems like everybody wants to do pretty much the same thing with their Android phone. They want to access all of the sensors as nodes, including the camera and gyroscopes and things like that. Is there anything that just does that? And Chad Rocky is actually working on the sensor driver, and I think that's his goal. So there's the sensor driver app that possibly right now only does orientation. But yeah, I think that's the plan. That was the, so the question was, what was the RViz looking thing running on the tablet? That is actually the visualization view that's available in the Honeycomb package, actually. And that's a XY orthographic OpenGL view that has multiple layers. So it has like a map layer, navigation layer, path layer, laser layer, all kinds of stuff. So is there something similar to RxPlot? Not that I've seen. Or yeah. Follow his hand.
If I'm not a rosjava user and there is no rosmake, how do I use resources that are needed by
Okay, so if you're a rosjava user and there is no rosmake, Oh, and you want to, okay, so you're not a rosjava user, there is no rosmake for rosjava. How do I use rosjava resources with the rest of ROS? Right, okay. Yeah, you need to, right now you would actually build those yourself or, download them from, some distribution mechanism. So, I mean, you can, as a package or a stack maintainer, you could write a pretty simple rosmake script that would just execute Gradle. And in that case, it would work. But I think there's not really a clear idea of exactly how that should be integrated right now. So, yeah, sorry, that's not a very great answer to your question, but it's a hard question.
When you were using the tablet PC and you were logged onto the robot and you had like those joysticks and
Yeah.
things like that, are you able to get those joysticks, like can you go from a web browser, or do you have to have it installed a certain app to get those joysticks?
Okay, so the question was for the teleoperation app on the tablet. Was it an app? Yes. Yeah, not via the web. I have seen things that are done over HTML5 though. Okay, so I just barely heard you, but I think is there a API for listing topics and services? Yes. Right, okay, so the question is, if I'm automatically generating all of these messages, how does something like Android figure it out? So originally I thought you were going to go towards, Android doesn't support dynamic bytecode generation, which is true, but this is not dynamic bytecode generation, this is called dynamic proxy. And it's basically Java sanctioned black magic. That's pretty awesome. There's really not a whole lot of performance hit there. Essentially, when you depend on the rosjava messages package, you pull in that jar, and that jar includes all of those empty interfaces, and all those empty interfaces contain the definitions of strings. And so that's where it finds it all. Did that answer your question? Oh, so how does the rosjava messages package find them all? And it does that by crawling your ROS path. Okay, so is there a particular version of Android required for running this? Yes and no. So the packages right now, the base packages for the Android type stuff, are named after the release of Android that is basically required for the features in that package. Currently, the lowest common denominator is Gingerbread. So can you tether your phone to your laptop and access rosjava? Yeah, maybe I don't understand the question, but I would say, it is a full implementation of ROS, so you could go on to your local network and access it just like you would anything else in ROS. How does the Android build system integrate with the new Gradle-based build system? Presently, the way it works is that since there is no official Gradle plugin or Maven plugin or anything for that matter for Android, actually the only Android command line build tools that are official that I'm aware of are for Ant. Actually, we use the Gradle and Ant compatibility. And so really the Android build tools are just wrapped very simply in Gradle. It calls the stuff for you, it calls the Ant scripts for you. And there is no Eclipse project generation on the command line for Android, so there is no Eclipse generation for rosjava either. Basically, the reason for that is that it's become too cumbersome to actually try to keep up with the Android changes to the Android build system, and so I'm working with them instead to hopefully make that easier for external tools to integrate with.